Good day to everyone. Today, we will now be discussing the Module 2. Module 2 is all about progression, and Module 2 is divided into 3 units. Unit 1 is arithmetic progression, Unit 2 is geometric progression, and Unit 3 is harmonic progression. So for this particular discussion, we will be focusing on Unit 1, which is the arithmetic progression. First, let us define what progression is. Progression is a list of numbers or items that exhibit a particular pattern. So this is your keyword. There is a particular pattern. There is a pattern that the list of numbers are following. The difference between a sequence and a progression is that to calculate its nth term, a progression has a specific formula. So for a sequence, again, when we say sequence, this does not follow a particular pattern, while a progression follows a particular pattern. A progression also, in order to calculate its nth term, a progression has a specific formula. There are 3 types of progression that we are going to discuss for this module. Number 1 is the arithmetic progression, number 2 is the geometric progression, and number 3 is the harmonic progression. First, let us be talking on arithmetic progression. An arithmetic progression is a sequence of numbers in which each successive term is the sum of its preceding term and a fixed number. This fixed number is called the common difference. Below is an example of an arithmetic progression. If the numbers below doesn't follow a particular pattern, this simply is just a sequence of numbers. 3, we take a look at 3. This is our first term designated as A1. So A1 is our first term. 6 is our second term, our third term, fourth term, fifth term, sixth term, and if it continues up until to the last term, which is ace of n. So ace of n is the nth term. Notice also that the difference between the second term and the first term is 3. Likewise, the difference of the third term and the second term is also 3. And if you're going to take a look at the following numbers, their difference with their preceding term is also 3. This is now your D, which is the common difference. If we go back to the definition of arithmetic progression, it says that each successive term is the sum of its preceding term and a fixed number. If we take a look at the second term, this is the sum of its preceding term and a fixed number. So if we check it, the preceding term is 3 plus the fixed number, which is the common difference, which is 3. So 3 plus 3 is equal to 6. Likewise, if we take a look at the third term, this is the sum of the preceding number, which is 6 plus the common difference, which is 3. So that becomes 9. If we take a look at the fourth term, this is simply the summation of the preceding term, 9, plus the common difference, which is 3, that is 12. So this is now the pattern for the arithmetic progression. Let us now derive the equations that are being used in arithmetic progression. So AP stands for arithmetic progression. We have here the same example that we had used previously, and we have our A1, which is the first term. So to get the value of A2, this is simply A1 plus the difference. To get the value of A3, this is simply A1 plus twice the difference. To get the value of A4, this is simply A1 plus 3 times the difference. To get the value of A5, this is simply A1 plus 4 times the difference, and to get the value of A6, this is simply A1 plus 5 times the difference. And this will go on up until to the last term, but we cannot be writing them all. So we cannot be writing them all. Thus, we simply replace this subscript into n And if we take a look at this constant here can be written as n minus 1. So for example, if this is 6, the value here is simply 6 minus 1, which is 5. Likewise, in the fifth term, if the subscript is 5, notice that this number is simply 5 minus 1, which is 4. 4 minus 1, 3. So this constant can be written as n minus 1. Thus, if we want to solve the nth term of an arithmetic progression, we can simply use the formula ace of n is equal to ace of 1 plus n minus 1 multiplied by the common difference. Let us now derive the working equation for getting the sum of an arithmetic progression. So we have here a series of arithmetic progression, the first term, the second term, the third term, until the last term. So again, the difference of the second term and the first term is D, the common difference. Same with A3 and A2, their difference is same as the difference of the second term and the first term. So to get the sum of an arithmetic progression, that is simply we add all the terms together. So S of n, that is the sum, is equal to the first term plus the second term plus the third term and so on and so forth plus the last term. But we have said a while back that to get the second term, that is equal to a1 plus the difference or the fixed number or the common difference. And likewise, to get the third term, that is a1 plus twice the difference. So substituting this equation into this equation, that becomes S of n, or the sum of an arithmetic progression, is equal to ace of 1 plus ace of 2. But what is ace of 2? That is simply a1 plus d plus ace of 3. But what is ace of 3? That is also a1 plus twice the difference. So a1 plus 2d and so on and so forth plus the last term, which is ace of n. We can also get the summation of arithmetic progression starting from the last term up to the or going towards the first term. So if we are going to do that, the summation of arithmetic progression is equal to the last term, ace of n, plus what is the term? So if this is the last term, we have here the second to the last term, and this is simply, the term here is simply the last term minus the difference to get the term on this part, right? So that is simply ace of n minus the difference plus the next term is ace of n minus twice the difference, and so on and so forth up until to the first term, which is ace of 1. So we now have two equations, and we simply add this together. So S of n and S of n, that is 2S of n, a1 plus an, that is a1 plus ace of n, and then the positive d and negative d will cancel out, so we are left with a1 plus ace of n. And then for the next term, 2d and the minus 2d will cancel out as well, so we are left with a1 plus ace of n, and so on and so forth up to the last term, which is an plus a1, so that is a1 plus ace of n. So notice that we have a common terms enclosed in parentheses. So if we are going to use factoring, or we are going to simplify this one so that it would not be a very lengthy equation, that is simply a1 plus an multiplied by the number of terms, so designated as n. And then we simplify further this equation. We divide both terms by 2, and the 2 will cancel out. Therefore, the sum of an arithmetic progression is S of n is equal to n divided by 2 multiplied by the first term plus the last term. We also have another equation to get the sum of an arithmetic progression. So notice that we already derived the equation for this one and the nth term. To solve the nth term of an arithmetic progression, we use this equation: a of n is equal to a1 plus n minus 1, the quantity multiplied by the common difference. So if we are to substitute this equation, if we are to replace it with the values of a of n in this equation, that is s of n is equal to n divided by 2 multiplied by the quantity a1 plus an. But what is an? We replace it with this quantity, so this becomes a1 plus n minus 1, the quantity multiplied by the common difference. And then we simplify this equation: s of n is equal to n divided by 2 multiplied by the quantity 2a1, so a1 plus a1, that is 2a1 plus n minus 1 multiplied by the common difference. So this is now the second option for us to solve the value of the sum of an arithmetic progression. So if we are going to summarize the working equations for arithmetic progression, to solve the nth term, we use this equation: an is equal to a1 plus the quantity n minus 1 multiplied by the common difference. And then for the summation of an arithmetic progression, we have two options. Either we use the first or the second, depending on the available given. So this one is used if we do not know the common difference, since there is no value for d here. And this one is if the d is given, the n is given, we can also use this equation. But anyway, both equation will yield to the same answer. Let us now consider some sample problems. Number 1, write the first 6 terms of the arithmetic progression. Given the first term is equal to 11, the common difference is equal to 3. So required, what is the first 6 terms and the solution. So we have no problem with the first term because it's already given. What we are to do is to find the second term, the third term, the fourth term, the fifth term, and the sixth term. So since the difference is given, which is 3, we learned from the previous discussion that the successive term is simply the summation of the previous term plus the common difference. So if we are going to apply that here on second term, that is simply the summation of the preceding term, which is 11, plus the common difference, which is 3. That is simply 11 plus 3. The second term is now 14. Next, for the third term, again, the third term is just the summation of the preceding term plus the common difference. So the preceding term is 14 plus the common difference, which is 3. 14 plus 3 is 17. Same with the fourth term. That is the summation of the preceding term, 17 plus the common difference, 3, that is 20. And for the fifth term, summation of the preceding term plus the common difference, 20 plus 3, that is 23. And for the last term, which is the sixth term, that is simply 23 plus the common difference, which is 26. So from there, we have the first 6 terms. We also have a second option if you want the longer solution with the use of this equation. So this is the equation for finding the nth term of the arithmetic progression. So if we are to find, say for example, a of 2, then that is simply a of 1 plus our n is 2 minus 1 multiplied by the common difference. So substitute, we know the value of first term, that is given to be 11. And then the difference is 3. So substituting, that becomes 11 plus 3 is 14 is the second term. So same with our previous solution, a2 is 14. Next, considering the third term, a3. a3 is equal to a1 plus 3 minus 1 multiplied by the common difference, which is d. So again, a1 is 11. 3 minus 1 multiplied by the common difference, which is 3. So A3 is equal to 17. So we also have the same value, third term, on our particular solution a while ago. So you can continue this to get the value of A4, A5, and A6, but eventually you would be arriving at the same values, 20, 23, and 26. So therefore, this is now our answer. Is it raining? Second problem, find the value of k if the sequence forms an AP or arithmetic progression. So 17, k, and 29, we are to find the value of k. So given, so let us, so first and foremost, we have to identify the given, and A1, that's the first term, that is given to be 17. And then ace of n, the last term, given to be 29. At the same time, we know that n is equal to 3. So again, n is the number of terms, that is 1, 2, and 3. So we are definite that n is equal to 3. Then solution. So we do not know the common difference. Should we have known the common difference, then we can simply add the common difference to this first term so that we'd be able to get the value of the second term. But we can solve the value of d by using this equation. So since ace of n is given to be 17, ace of 1 is also, ace of n is given to be 29, first term is given to be 17, we know the value of n, we only have one unknown, so definitely we can solve the value of d. So substituting this equation, that is 29 is equal to 17 plus 3 minus 1 multiplied by d, one unknown, solvable, so d, or the common difference, is equal to 6. So from there, to solve for the value of k, that is k, that is also the second term. K is equal to the second term, which is equal to the preceding term, 17, plus the common difference, which is 6, is equal to 23. So k is equal to 23, and this is now our answer. Next problem, given the terms 2, 5, and 8, find the 61st term. So given, it's very important that we have to identify the given. So A1 is equal to 2. And then what are the other given that we can identify? We can identify the difference, right? So since we can identify the difference, that is 5 minus 2, d is equal to 5 minus 2, that is 3. So if we are to check, 8 minus 5 is also 3. So the common difference is 3. And we can also say that the total number of terms is 61. Required, what are we required to find? We are to find the 61st term, or that is ace of 61. Alright, so solution. We can basically use this equation, ace of n is equal to a1 plus n minus 1 multiplied by the common difference. So the common difference, as we have solved from the given, that is 5 minus 2 is equal to 3. So substitute, we know the value of a1, we also know the value of n, we know the value of d, we can simply direct substitute the equation. So that is a61 is equal to the value of a1, which is 2, plus n is equal to 61 minus 1 multiplied by the common difference, which is 3. A61 is equal to, or the 61st term is 182, and this is now our answer. Next problem. Insert the 5 arithmetic means between 13 and 11. So we have here the given. First given, that is the first term, is given to be 13. And at the same time, we can identify that n is equal to 7. We are certain that the number of terms is 7. That's because it says there are 5 arithmetic means plus the two extreme values 13 and 11. Therefore, n is equal to 7. And then, of course, ace of 7, that is also given to be negative 11. So we are required to find ace of 2, ace of 3, ace of 4, ace of 5, and ace of 6, or the 5 arithmetic means. So these are the means, 1, 2, 3, 4, 5, and the two values, the first and the last value, this is the extremes. So solution, again, our goal is to be able to find the value of d, so that when we will find the value of the common difference, we can simply add the previous term to the difference for us to get the successive terms. So we'd be able to solve the value of d by using this equation, since we know the value of ace of n, or the last term, given also ang value ng ace of 1. We know the value of n, and we are left with one unknown, which is the d, which is what we want to solve. So substituting ace of n, that becomes ace of 7, is equal to ace of 1 plus n minus 1 multiplied by the common difference. So ace of 7 is given to be negative 11, ace of 1 is 13, n is given to be 7, and then the unknown term, which is the common difference, d is equal to negative 4. So since we already know the value of negative 4, we can now apply the rule, which is the successive term is simply the summation of the preceding term plus the common difference. So if we have here our first term, our second term is 9. That is because 13 plus the common difference, which is negative 4. So that is, we add 13 plus negative 4, that is 9. 9 minus, or 9 plus negative 4, that is 5. And then 5 plus negative 4, that is 1. And then the next term, that is 1 plus negative 4, that is negative 3. And then next one, negative 3 plus negative 4, that is negative 7. And the last term is negative 11. That is the last term. So if we check, is negative 7 plus negative 4, negative 7 plus negative 4 equal to negative 11? Yes. Negative 7 plus the difference, negative 4, is equal to 11. So therefore, this is now our answer. Alright, so our last number, find the number of all even numbers from 0 to 420. So again, the very first step in our approach to solving a problem is to identify the given. So given a1 is equal to 2. Why did we use of 2 and not 0? That is because we are talking about the even numbers. We are considering the even numbers that is in between 0 to 420. So therefore, our a1, the first even number just right after 0 is 2. So a1 is equal to 2. And our last term is 420. We adopt this as our last term because 420 is an even number. So that is ace of n is equal to 420. What is the required? We are required to get the sum of the even numbers. So solution. First is, we know that we can create the initial series or initial sequence for these even numbers from 0 to 420. So our first term is 2, and we know that the second even number is 4, the next even number is 6, and then 8, and then 10, and so on and so forth until we reach 420. So from here, we can identify the difference, the common difference, and that is 4 minus 2 is 2. So our common difference is 2. Likewise, 6 minus 4 is 2 also. And if we are to continue considering the next term here, which is 8, 8 minus 6 is 2 also. So therefore, our common difference is equal to 2. Now, checking on the working equation for the summation of arithmetic progression, again, we have two options, and we can see from both options that if we are to check the first equation, we have the value of a1, we also have the value of the a's of n, but we do not have the value for n. And likewise, if we check the second equation, we have the value of a1, we have the value of the common difference, and we do not know what is n. So the next step that we have to do is to solve the value of n, so that once we know the value of n, we can substitute any of this equation. So to solve for the value of n, we will be using the nth term equation, which is a's of n is equal to a1 plus n minus 1 multiplied by the common difference. So this is given. We know this value. We know also the value of the first term. We were able to determine also the value of the common difference, and we are left with one unknown. So from here, from using this equation, we can solve the value of n. So let us now substitute. Our last term is 420 is equal to the first term, which is 2, plus n minus 1 multiplied by the common difference, which is 2. So from here, n is equal to 210. So since we already know the value of n, we can now substitute it to any of this equation. So first, let us use this the first equation. So substituting, the sum of the 210 terms is equal to n divided by 2, and our n is 210 divided by 2, multiplied by the quantity, the first term. First term is a1, first term is 2, and then last term is 420. So sum is equal to 44,310, and this is now our answer. So we can use also this equation just to check if they will yield the same values. So using this equation, we substitute s of n is equal to, the value of n is 210 divided by 2, multiplied by the quantity, 2 times the first term. Our first term is 2, so 2 times 2, plus, again, n is equal to 210 minus 1, multiplied by the common difference, which is 2. So this will yield an answer of 44,310, which is also the same with our previous answer. So therefore, this is our final answer.